everyone, welcome to day 6 of our notes. We are on unit 10, day 6. We're doing logs, we're having fun. Let's do it. All right, so find the inverse. So what do? We got to flip them. So we got x equals y to the third plus 8, or y cubed. Now I need to isolate the y, so I'm going to subtract 8 to both sides. X minus 8 equals y to the third. And how do we get rid of the cubed? We cube root, and make sure we cube root the whole thing. So now my answer is y equals cube root x minus 8. The next one, reflect the graph over the x-axis and move it up 7 units. Okay, so if it's across the x-axis and I have point, let's say I had point -5, 2, and I wanted to change that, well then the x will have to change to 5, 2. So think about that when you're reflecting. Okay, so how would that happen on the x-axis? And then it's also moving up 7 units. So I know that the 2, I'm going to add 7 to it, so it's going to be plus 9. And in order to get a reflection, I'm going to make this x negative. So I have 7 to the negative x plus 9. And that would be my new equation. Okay? All right, describe, what if it said across the y-axis? Y-axis, what would change? Well, you'd have the negative in front of the 7 if you wanted it on the y-axis. So just knowing the difference between them and practicing, plugging it into your graphing calculator and see what's up. All right, end behavior. So a big key for this is the -9. Okay, so I have my asymptote would be at the -9. It looks like it is a exponential growth, so it would be starting off low, starting right above the -9 and then increasing. So what does that mean for my end behavior? Well, when x is as x is approaching infinity, f of x is approaching infinity also. It's going up. As x is approaching -infinity, okay, what's happening with the f of x? Well, f of x is getting closer and closer to that -9. And there we go. All right. Now let's get rocking with our lesson today. Okay, so we're solving exponential functions. So we're going to have some equal signs. What? An equal sign. Get the same base on both sides and cancel the bases and equate the exponents. Okay, so we want the same base, so then we can make equal the exponents. We're going to isolate the base, okay, and take a log of both sides, then use the properties of logarithms. Okay, so just so you guys know, this is option 1. This is if you can make the same base. This is option 2. If you cannot make the same bases. Okay, so I would not, plug in a log of both sides unless you really have to. We want to, as best we can, get the same base on both sides. Okay, all right, so let's try this out. So number 1, if you notice, the bases are the same. So therefore, we make the exponents equal to each other and solve. Subtract the 2x to both sides, -x equals -1. Divide -1 to both sides, x equals 1. There we go. The next one, okay, how would I make 8 change it to a base of 2? Well, 8 is 2 to the third. This is very important. Then I have the x plus 3. Then I times it by x plus 3. Make sure you're going to be distributing that. Okay, and then I have 2 to the x minus 1. All right, so again, I changed the 8 to 2 to the third. Therefore, the bases are the same. And I equate the exponents. Okay, distribute and solve. 2x minus 1 equals 3x plus 9. And move things around. So I'm going to actually move the x over here. So I'm going to subtract 2x to both sides. I get x plus 9 equals -1. Subtract 9 to both sides, and x equals -10. All right, the next one. So both of these I need to change. All right, well, I noticed that I can make the bases 3 for both of them. So 9 is 3 squared, and I put the x next to it, and 27 is 3 to the third. Okay? From there, all right, equate the exponents and solve. Divide 2 to both sides, x equals 3/2. There we go. All right, so I want you guys to look at these next ones. A little bit more complicated, but we can kind of see where we're at. All right, so 3 to the 1 minus x. How can I change this 1 over 27? Yeah, 1 over 27 is 3 to the negative third. Okay? So you can also think, oh, 1 over 3 to the third, and then I can move it up and make it negative. All right, there we go. Now I'm going to make these equal to each other. So 1 minus x equals negative third. Move over the negative 1. And divide the negative 1 to both sides. And x equals 4. Okay, it's one of those things that it seems pretty easy, but you don't want to make little mistakes. So I'd highly recommend you working these out. So I want you guys to try number 5 and check back. So for number 5, you should have gotten x equals negative 1/2. Okay, so make sure you show that work. All right, number 6, 8 and 16. Well, you can take a 2. Both of these, you can have the base of 2. So 2 to the what gives you 8. And then you're going to times that by 3x plus 1. And then 2 to the what gives you 16. And then you're going to times that to x minus 5. All right, so try that one. You're going to distribute and check back. All right, so for number 6, you should have gotten x equals negative 23 over 5. All righty. Okay, number 7, let's work out. How would we get this 1 over e? So that's e to the negative 1. And then I have e 2x plus 1. Now let's make our exponents equal to each other and solve. So find the answer for x. So then you have x equals negative 1. All right, the next one. So when you have the same base, you add the exponents. So you have 10 to the 4th over here. And then you're also going to want to add these exponents together. So how many x's do I have? I have 3 x's. And then 3 plus 7 is 10. Now we have the same base. We make the exponents equal to each other. And go gadget. So then I have negative 6. And x equals negative 2. All right, number 9. If this stresses you out, you can flip it around. Sorry. All right, number 9. Again, a little bit harder to unpack, so let's look at this one. All right, so we have 4 to the 2x times 1 over. So 1 over 64 is 4 to the negative third equals 4 to the 5x plus 10. Okay? So because these are the same bases, you're going to add the exponents. So I have 4 to the 2x minus 3. Okay? And then over here is 4 5x plus 10. Once the bases are the same, again, equal the exponents and rock and roll. Okay, so sometimes it's a little tricky. If you see a fraction, chances are you're going to have a negative exponent. Okay? And if they're multiplied together, you add the exponents, or in this case, it's 2x minus 3. All right, and then what I call it is the car wash. I want to put my x's together, and I want to put my numbers together. So I have 3x equals negative 13. Divide 3 to both sides, and x equals negative 13 thirds. Woohoo, thirds. Again, sorry, some things are just not pretty. You can plug it back in and see if that answer works out. All right, moving right along. We're getting there. Okay, so I want you to try out number 10. What would you have to change for the 25? And go from there. And SpaghettiOs, this one has a no solution. The x's went away. They cancel each other out, and you had negative 1 equals 2. That can't be it. So you don't have a solution for x for this one. All right, what should happen when I have a fraction? You need to think negative. So 7 to the negative what on that side? And then 7 to the 5x plus 1. Then you'd have 5x plus 1 equals what? Okay, well in this case, 7 to the negative 3 would give you 343. So this is negative 3 on this side. I have negative 4 equals 5x. Divide 5 to both sides, and x equals -4/5. All right, we're almost there. One more. One more. Okay, so let's look at number 12. Well, this one is pretty hardcore, guys. Sorry, we have 3 more. One more like this, and then we have to do ones where the bases don't work. So 2.5 is 5 halves. So I'm looking to see this 5, and then this is 125. So how on earth can I get from 5 to 125? Well, that base would be 5 to the 3rd to get to 125. And then 2 to the what would give me 8. Well, that's 2 to the 3rd. Okay? Now we have the same bases. A little bit more tricky because we've got fractions in the mix, okay? So what would I do on this side? Well, I would put it to the 3, then times 2x plus 4. All right? Now we can rock and roll. 8x minus 4. I don't know why I keep saying that. Just for fun, I guess. So 6x plus 12. Woohoo! We got this, guys. So I distributed, and now we're going to solve. So I'm going to subtract 6x to both sides. I'm going to add 4 to both sides and get 16. And then divide and get 8x equals 8. Woo! So again, keep looking at those bases. If you got a fraction, see, can you break it apart? If it's a fraction, do you have a negative exponent? Keep trying, okay? All righty. Now, the last 2 examples, I'm going to turn this around. The last 2 examples of these are solve each exponential equation by taking a log of both sides. Now, why do we have to do this? Because you can't come up with a base. Then round your answer to the nearest tenth. So again, let's remind ourselves before. So when you have log 10, 10, okay, to the b, what happens? Well, this cancels out and your answer is b. The same thing is when you have natural log e to the a. These cancel out and then you have a left. So that's our mission, okay? So 10 and 17, I can't change either of these to make the same base. So therefore, I'm going to plug log into both of them like so. Okay, and if you notice on this side, log, there we go, we can cancel that out. You can cancel that out, and then you have x equals log of 17. This is a little bit different because, or you can, again, put the x in front, like so. You know, you've learned that before, and then the same thing, this cancels out, and you have x left over. Then x equals log of 17, and then let's solve that by plugging it into the calculator. And your answer is x equals 1.2. All right, so again, we put log on both sides and then solve from there. All right, for this one, because it's e, we're going to be doing natural log and seeing what's up. So again, these cancel out, and my answer is x equals 7. And there you go. All right, so thank you so much for joining me on day 6, and we will see you in the halls, and have a great day.